Have you ever seen heat sinks slide into rails? Oh, engineering students, take notes. Wow, look at the module. They've built a cube in there. Hi, it's vintage computer time again. Got this one from the bunker, dusted it off, and we've got an absolute classic from 1979 here. This is the HP, none of that Agilent or Keysight rubbish, HP 9845B. What is it? It's not a personal computer because this is a proper professional engineering industrial type computer. You couldn't really afford this at home because this had a starting price point of $14,000 US, and that's 1979 dollars. So yeah, what's that in today's money? Don't even want to think about it. But this was a professional workstation, I guess you could call it. And this one comes from HP's classic 9800 line of calculators that they had previously, and it stems from the 9830 was like the previous best calculator that they had before they went to this, the 9845. The 9830 series calculator slash computer was, a huge hit at the time, but they wanted to move into like the actual, a proper computer instead of like a, single or multi-line sort of like calculator display. They wanted a full CRT computer display system. So they developed the 9845, which there was an A version before this one, and that came out in 1977, and that was a big hit. Once again, very expensive at the time, and this one came out 2 years later, the B version, and there was eventually a C version as well after that. Before it, pretty much by like the mid-90s, this was pretty much like gone the way of the dodo. But in the late 70s and early 80s, this bad boy was the duck's guts. Because you got to remember, 1979, what else was around then? Well, the TI 99 4A came out. You had like the Apple II, none of that Apple IIe rubbish, the original Apple II. You had the Tandy TRS-80 Model 2, for example, which I also have down in the bunker. Thumbs up, comments down below if you want to see a teardown of that one. So that's real in crusty condition. But anyway, I've got one. And you had the Atari 800 and other types of personal computers back then, but they were sort of like low end. They only worked at a couple of megahertz. Everything, this was limited. Whereas these graphics workstations, so to speak, it came with a big CRT on top of it. Sadly, I don't have it. That plugs on the top. That's what these two mounts here are for. And you could display up to 560 by 455 graphics, and that was like state of the art at the time, monochrome, none of that color rubbish. But the graphics on this sort of thing was so good and so easy to use. Rumor has it that George Lucas actually loved the 9845 computer and the graphics, and he actually used one of these bad boys to help design some of the scenes for Empire Strikes Back. Unfortunately though, the B model like this only lasted like 2 years before they introduced the C model, and the C, coincidentally, was the color model, and it was incredibly advanced for its day, and that's what they used to capture the graphics and generate and capture the graphics for war games. Those famous war room, computer large graphics screens, they were all generated with the 9845C model with a camera capturing the monitor, the actual CRT display, and it was all finely tuned, and it was like incredibly advanced state-of-the-art color graphics for its time. So that was announced in 1980, came out in 1981. So that was still one of the state-of-the-art ways to generate color graphics for like computer type color graphics that they wanted for a movie like War Games. So very impressive stuff. This was a powerful beast, and this was a 16-bit computer in the times of, just little 8-bit like Z80 and 6502 processors, and not only single CPU, this is actually dual CPU. They actually had one dedicated to like the peripherals and I/O, which we'll see on the back, and one dedicated, they called it like a language processor dedicated to executing the basic language system, because pretty much this was a basic computer, although it uses HP's extended basic, which was pretty powerful in terms of doing graphics and plotting and all sorts of fancy data stuff and things like that. So it was much more advanced basic than a lot of the personal computers of the day. And memory, this thing either had 16K or 32K just dedicated to video memory. So yeah, none of that sharing the memory rubbish with your main memory, which started from a 64K and went up to like 1.5 meg in this B model. So, you know, 1979 to get like 1.5 meg, that was a massive amount of memory, and you could hook external disk drives and hard drives up to it as well. But geez, if this thing was $14,000, imagine what the hard drives and external disk drives cost. It's got dual tape storage as well, 217 kilobytes per tape. None of that standard cassette rubbish. These were like HP's tapes. I'm not sure what other systems they were compatible with, but yeah, dual tape so you could make backup copies and everything else. External storage solutions, as I said, and internally 1.5 meg of memory. And the CRT that sat on top was actually powered from the unit. It's one of the amazing things about this, as we'll see on the back and as we tear it down, there were basically no cables for this thing. It was power cable in, and that was it. Everything was actually powered through the top. The monitor and the graphics were actually powered through the top here. One of the interesting things about this was not only that it was that all powered through here, but the actual graphics processing subsystem was inside the monitor as well. So this actually has no I/O connections on it. It's got no monitor outputs, it's got no serial outputs, it's got absolutely nothing. There are no ports on this, but as you'll see on the back, there's like expansion slots that hooked in directly into the bus inside this thing. So it had dual 16-bit processors which ran at a nominal 11 megahertz. So this was like a real powerful beast for 1979, early 1980 technology. It was absolutely amazing. But as I said, it actually ran BASIC for almost everything. In fact, the user really didn't have any other option but to use the built-in BASIC. Now, there's no such thing as assembly language for this thing. They actually called them binary programs, and really the only one who could write binary programs for this thing were HP and a couple of other major software developers, I believe. So I don't think, correct me if I'm wrong down below, but the user had no way of actually writing, you know, machine language for this thing. You had to do everything through BASIC, but you could load binary programs from the tape and they would execute faster, and they'd execute in CPU microcode as well. Winner. And you can see it had a built-in thermal printer as well. That might have been optional, as was the second cassette, I believe, for one like the base model. Geez, you pay your 14 grand, I think you only got a single cassette. But it had really excellent capability to like dump like the screen and graphics and plotting capability. You could get external plotting interfaces, and HP of course were big in the plotting market, so you could hook this up to huge industrial plotters for doing, you know, huge like, you know, schematics and other engineering CAD drawings and things like that. Really remarkable for the day. So yeah, this would have been a huge expense for any company, but this would have been like state-of-the-art engineering workstation computer, I guess you could call it, for engineering, scientific, laboratory use, all that sort of, you know, research use and things like that. It also came in a Tempest model, which is a like electromagnetic shielded one for the government and the military. So yeah, I guess that was popular. Wonder how much that one cost. So as you can see, it's rather large and deep and rather heavy. So let's have a look and do a teardown of this bad boy in 4K resolution. Oh, winner. And here it is. Isn't it beautiful? It looks like, you know, like a modern computer should look like it. Well, at least in 1979, 1980 anyway. I mean, it's just, and you know, it's just beautifully styled, enormous beast, hugely long. There's the length of my arm for reference there. It is a big, heavy beast. And if you want all the details on this, check out the website hp9845.net. It's got absolutely everything you could possibly want on this, including all of the people who worked on this. And generally, they're not quite sure who headed the B series project, but generally Jack Walden and Bill Eads is the two that managed the A project and worked on the C as well, so they probably managed the B project. But yeah, there's a whole bunch of, they've got, you know, a good lot of the names of the people who worked on the firmware, the hardware and the casing. The style of the casing, the industrial design, it was done by Leroy Lassell. So yeah, it's a really good job. I mean, this looks like a professional bit of kit. First of all, we've got our printer up here. Obviously, there was some sort of like roll thing that went in there that held the paper, which I obviously don't have. There's just a little slip of paper left inside this thing. Then you've got some paper advance and top of form buttons. And then you've got the two cassette mechanisms. These are rather interesting design in that you might think, well, how do I eject? How do I get it open? Oh, there it is. You just press that and you slide your cartridge in there like that. It is rather nice. And then the eject will actually then physically eject it back out. That's a rather clever design. I really like that. And then if we go down, we can have a look. Now, if we check out the keyboard here, you can see it really, it hasn't really stood the test of time. Tried to clean it up a bit, but it's obviously got like lots of, I don't know if that's eventually going to, that sort of darker color's eventually going to come out of it or not. But yeah, it didn't clean up that well. So unfortunately, I don't know if you got any ideas about how to fix it up. Yeah, I know about retro bright and all that sort of stuff. It's not, I don't think it's yellowed. I don't know if these keys have gone extra yellow. I don't think so. I think it's looks in, a fairly original color. It's just that, yeah, it's got some stains and stuff on it. But anyway, it's got like typing functions, tab set, tab clear. Brilliant. It's got edit system functions, so step record, delete char, insert line, and all that sort of stuff. Auto ST, I guess auto step or something, that button. Oh, did come up. Oh, it's a little bit stuck. Then you've got all your display stuff. You can actually clear the display. Then you've got cursor keys and roll keys as well. Then you've got 16 function keys over here, which also have some secondary functions as well. And on the C model, these doubled as like color buttons and stuff like that. Invert video, that's interesting. Blink in cursor, underline cursor, I guess. You can change between those. Then your main QWERTY keyboard here is pretty traditional. And then you've got, stop, run for your programs, because this was all, you've got to remember, this was all basic program oriented. And from all reports, this thing is like just very nice to use. And that's why everyone loved it. It was just simplistic design. It was designed for a single purpose, which was to run, HP extended basic programs extremely well and extremely fast. So much so that the basic commands were actually microcodes inside the custom CPU inside this thing. So yeah, it did actually, execute pretty quickly. It wasn't just your generic processor running a basic interpreter. It's, they actually optimized this whole system for running the basic programs. And that's just a beautiful numeric keypad. I love that. It's got an execute button. I love that. Brilliant. So yeah, stop, reset, run, pause, continue for your programs. It was all just oriented around that. Like you didn't do anything else on it. There was no, word processing as far as I know. I don't know if you could even run, was there a spreadsheet program for this thing? I don't know. Anyway, I think that's absolutely beautiful. Let's swing it around. And the backside of this, as I said, there are no traditional I/O connectors on this thing at all. There's power in, which you could switch between 110 and 220, made in the USA. Two gigantic fans on it, the thermal design we'll have a look at when we open. I'm not sure where probably sucks air in from the bottom because there's no side vents that I can see. And the rest of it is just like these expansion headers down here. We've got 4 expansion headers, which, as I said, are designed to plug in these cartridges. Basically, think of them as like PC plug-in boards, your ISA plug-in boards, essentially, or your bloody whatever you got these days, the newfangled micro-channel rubbish, or your PCI Express ports for you kiddies. But basically, you plug in these expansion cards and they would have, RS-232 serial interfaces that have plotter interfaces, printer interfaces, external mass storage interfaces, a real-time clock, because this didn't have a real-time clock in it. You had to plug in an external one. It's like, you just plugged them in there and you could get an expansion cage which had an additional 7 slots as well. There you go. This is probably the only computer you'll ever see without any connectors on the back at all. Name another one. Aha, there we go. That's where it sucks the air in from. The bottom, the case curves down here. Got some standoffs here, and it sucks in the air from the bottom, and they're not normally open like that. Normally I wouldn't be able to poke the boards in there, but the foam has just completely disintegrated. Obviously they had a filter on there, And, oh, yep, there we go. Yeah, what's left of the foam is just, yep, it's just disintegrated with time. Ugh. Yeah, there it is there. Yucko. So this was designed by engineers for engineers. So I expect this to be a Bobby Dazzler inside. Let's crack it open. For those playing along at home, there you go. Shipped the 13th of the 12th, 1979. Terminal 4003, I don't know what that means. Ah, almost forgot to show you the interface for the monitor here. There's two of these. As you can see, big card edge connector along here. A big robust, metal clippy thing. And is that for like EMI or something like that? But yeah, it's big and robust, and the monitor's designed to connect into here. So this is power, and bus and everything else. Because as I said, these aren't video signals traveling across here because there is no video circuitry inside this thing. The video circuitry to generate all the signals is inside the monitor. So yeah, we're not going to find a graphics card. All right, let's see if we can lift this bad boy off. Oh yeah, that just comes off. Oh, look at that. Ah, beautiful. There's not much dust in it either. Oh, look at this. There's a handle. Trained service personnel only. Oh, beautiful. If you have a look inside the case, you can see the metal braiding around there for EMI, stuff like that. Is it got, I don't know, what is that? That feels really rough, that coating. I don't know, is that some sort of like silver nickel screening or something? That wouldn't surprise me at all. I wonder if that's conductive. Let's try that. Yep, yeah, called that one. Dead short. Absolutely no surprises for finding, removable board construction like this, color-coded. So, we've probably got, we're going to have a mix of memory and CPU and other cards. And it looks like we're not fully populated either. So this thing is obviously not fully expanded. And of course, yep, test points, beautiful, 12 volt, logic ground, +5, -12, +18, that's unusual, plus -18 actually, 175 volts DC max, that's interesting, why I've got 175, is that for the monitor, perhaps? Anyway, there it is over there again, why do they need that? Yeah, it's got to be for the monitor. And everything is modular, look at this, even the back plane on the back comes out, and that's just a modular card like that. That is beautiful. Made in the USA. Rev E. Oh, fantastic. 74LS 367s. And oh, look at that. And that'd be a hand taped jobby too. That's just beautiful. That connects down to the bottom but motherboard and then the expansion connectors. Like, I don't even have to, I think even this back panel assembly is a modular design. Looks like it just comes out the fan assembly and the back of this. Ah, fantastic. So I unscrewed this little bracket here. That came off, but I still can't get these cards out without actually lifting off the keyboard. And it looks like it's hinged. So, can I... Oh, is there a... Oh, no. Oh, look at that. Look at that. Oh, it's not actually hinged, but it comes out. And the great thing about this... Oh, is that you can access everything. Beautiful. So you can still access everything and power this thing on. And of course, as I said, designed by engineers for engineers, basically. And they would have had their own extender cards and stuff like that. So if you wanted to probe a board, well, it's, this one here, for example, then you could lift it out, put in your extender card, lift it up, and the board would be up here like this. Then you'd be able to probe it. Well, the whole thing's operational, and it looks like all this stuff over here, you can access and probe all that. We've got access to our tape mechanisms. Ah, beautiful. And here's one of our processor modules, because as I said, there is two. There's one called the PPU, or the Peripheral Processor Unit, that handles all of your I/O and your CRT interface and all that sort of stuff. And then there's another CPU, which is called the LPU, which is a Logical Processor Unit, which, as the name says, it processes all your basic programs, contains all the microcode to run all your basic programs. It's effectively your CPU. And you can see we've just got standard 7.4 series logic. There's that source, 7.4 LS stuff, none of that high-powered stuff, none of that F series rubbish. And apparently they were actually the same unit, but basically they just had different functions. So I'm not sure what the deal is there. I guess they wanted to reuse their custom silicon, which is under this heatsink here. So all the rest of it's just, pretty much Jelly Bean 74LS series glue logic. Let's have a look on the bottom. Oh, might need that bracket. And yeah, no, there's no bodge wires or anything like that. It is a 4-layer jobby. At least you wouldn't need any more than that. But yeah, the old, the square traces, all the electrons are just going to fly off the corner. It's terrible. Like, no, the traces at an angle, odd angle like that. Oh, no. But anyway, here's where all the magic happens. This is the hybrid module down here, which actually contains 3 chips. It's in a metal can package like this. And I think if we take the heatsink off, I think we still can't see inside. I think you've got to butcher it to see inside. Anyway, I should be able to include a photo here that has that, so we'll check that out. But anyway, so yeah, made in the USA, contains 3 chips. One is the BPU or binary processing chip, and it's, as its name suggests, it actually does the actual processing and all that sort of jazz. It's the CPU, and then you've got the EMC, which is the extended maths chip, and that does floating point calculations. So yeah, this thing contained a floating point coprocessor, basically. And then there's the IOC, which you can guess that one. That's the IO controller type stuff. Handles all the interfacing and interrupts and all sorts of other paraphernalia. But yeah, it's basically 3 chips inside that bad boy. Well, there you go. No one was going to be happy, were they, unless I took that apart. And, well, there it is. Yeah, it's a ceramic hybrid. Looks like it's, I think it's bonded on there. And of course, we're not going to pry that can off. So yeah, not even going to try. Anyway, yeah, it's a ceramic interesting construction. A ceramic hybrid like this. And then they've got like zebra strips around here. They've got like a sheet which just goes in there like that. And there you go. There's your gold-plated. Thank you very much. That'd be real heavy quality gold plating. None of that, thin crap they put on these days. And that just works like a zebra strip to the matching contacts on the board. Isn't that neat? I wonder how they came to that design decision. Well, I guess because they had like a 3-chip solution, why you wouldn't just, maybe the manufacturing technology at the time just wasn't there to put that on fiberglass, those, bond those chips and then bond them over, wire bond them over onto fiberglass PCB. Maybe at the size, I don't know, at the size and complexity they were. Was fiberglass PCB direct bonding a thing? Back in, well, this was released in end of 79, so, and then basically, well, it comes from previous designs as well, so, yeah, it's like, it probably started work on this in, like, the mid-70s, so, yeah, I can see why they did that. Back when you rolled your own stuff, though, thing of beauty, joy forever. Now, hang on just a minute. What is going on here? All of the blue ceramic capacitors on this board have what looks like, are they ferrite beads? Are they little ferrite beads, or are they just spacers? I don't know. I think they're ferrite beads. Every single capacitor on the board. Has anyone ever seen that before? Anyway, clearly we have our PPU or LPU board here, and then obviously, and that's either the PPU or the LPU memory board. I'm not sure which. It doesn't actually tell you. Doesn't know. You'd have to look up the part numbers and whatnot. Anyway, anyone, they're 4160s. So does anyone want to calculate how much RAM's in this thing? Anyway, you could get 512K boards for this thing. And yeah, as I said, you could put 3 of those in here to expand it to 1.5 meg. Unbelievable. And the other board here, which contains RAM, this actually contains 4 116 chips, and there's 16K times 1. So there's like 2 rows of 16 there. So that's 16K, 32K, and that's 64K total. That's more than the maximum 32K video memory inside this thing. So I've got to say that this one here only has 64K of CPU memory, unless we've got more on the other side of the unit on a separate board. I think this is a minimum configuration of 64 K, and these Mostec jobbies, they look like the ROMs up the top. Although curiously, they seem to have different part numbers. There's 36151s, there's 36171s. Not sure what the deal is there. 070s? What? And this is hilarious. Look how they've routed this. Up and around instead of through. That's hilarious. Come on. Look, they're able to go through here, although you'll notice that the solder mask, I can see some solder mask exposed in there. So, yeah, that was really fine pitch for the day. Whoa, they didn't get these for $2 from China. So to answer the question, going back to here, they've used UPD 416Ds, and once again, these are 16K times 1 DRAM. So 16, there's 32 in each row, that's 64K, and double that is 128K. So obviously, this is not the video memory either. This looks like the processor memory or extra processor memory. And as you can see, these slots are all color-coded. Red and blue like this indicates that, well, red and blue, that's your memory expansion card. So that bad boy can go in there, and we could have put up to 3 extra memory boards in there. So, I don't know, maybe that one, and this is grey here, and so maybe that one is CPU ROM and video memory as well, or is that video ROM? Nah. Anyway, the other board we got down in there, that just extends up to here. That goes up to the CRT. So that's obviously like the CRT interface. It's all just 7.4 glue logic. Hey, what is this down here? There's almost as if this slides out. There you go. This drawer is only for ROMs having black labels. Okay. It's a graphics ROM. It's a ROM cartridge thing. There you go, graphics. You can plug in little graphics modules. Isn't that cool? Geez, there's not much room on there. Oh, look, there's another, that same ceramic hybrid thing. Look at that. Wow. Now, I've heard that the C model is quite similar to the B. It's just really the graphics are different. Does that mean that they've added, like, other graphics ROM stuff in there? Wow. That's fascinating. You can see the contacts on there. They're only single-sided, like that, and then the contacts are on one side like this. So you, like, don't know if you can plug it into any slot, but presumably you can. Isn't that absolutely fantastic? And then that just buggers off over to here. That hasn't got, oh no, it's got double-sided. There you go. Wow. Here you go, option ROMs. So there you go, you could like expand the graphics capability and presumably other functions. I don't know if you could actually get, maybe you could get programs to plug into ROMs. I mean, there's a lot of them. That's fantastic. I love that design. Wow. That is brilliant. And yeah, here you go. Here's the other LPU and here you go, here's the other processor board, the LPU or the PPU. I still haven't bothered to match up the part numbers. Here, the processor is on the other side, and yes, it is absolutely identical. 5061301D, made in the United States of America. Presumably that's the test date, 70 manufacturer and test date, 79 year, 40th week, and number 87, maybe? I don't know. Actually, I'm pretty sure, given the location of this, next to the next memory board, that was the PPU or the peripheral program unit, because that handles the graphics interface. And obviously, we've only got half the amount of memory, 16K, 32K, and I know that that's the amount of maximum video memory in this thing, and that's probably the graphics ROM right there. And this is your printer control logic card, and that is right next to, ta-da, there it is. And I find it quite offensive that this one goes in this direction and the CPU and other boards go in that direction. So, yeah, I don't know how they could live with themselves designing that. Anyway, there you go. That's just the printer interface board, and I guess that needs a fair bit of power, so it's got its own little connection interface like that. And you can see the cables from that buggering off there, but also this goes up once again to the CRT up here. That board actually extends all the way up there. So that's interesting that it'd go through the printer control card like that. I guess from a physical layout. Oh no, look, check out the traces. Hang on. No, you can see the traces. Look, they're all bunched around and bypassing and going straight up there. So yeah, they're just using physically the printer interface board. I guess the printer only needs a couple of, not much interfacing at all. And I don't know, it could be a serial jobby. And the rest of it's, just dedicated going up to the CRT. Neat. For the crystal socket aficionados and for the ceramic package aficionados. Look at that. Somebody's written, minus 5.0 volts. No, that 5 volts rubbish. 5.0, thank you very much. Now, I know people want to take a look at the power supply in this thing, so let's see if I can get it out. Now, I'm pretty sure that you don't take out these screws here because, like, these big-ass screws here, C17, that doesn't have a designator, but they're obviously two big-ass caps there going right down the center. So they're probably like the full height of the damn thing or something. I don't know. Well, not quite, because there's a motherboard on the bottom, isn't there? And I don't think you undo these screw bolts here. T2, that's not Arnie. That's, that's holding in the transformer. Probably, and these are bolting in something else. I don't like big ass crimp interface or something. I don't know. So I think it levers out because there's another motherboard connection here. So I'm gonna and there's some heatsink fin in here. So let me gently. Oh yeah, that's giving. Yep. Pop goes the weasel. So yeah, I was clearly supposed to pull this entire assembly out with this handle, and I did actually try that, but I could not budge it. Hence why I took off the 4 threaded insert screws down in here. So maybe it's just age probably. Can we? Oh yeah, there we go. No wuckers. I know people are probably cringing at the moment, but that's supposed to. Does that come out? Yes, it's all discharged and everything. Hasn't been powered up forever. So, oh, hello. Yep. Oh, no. Look at that. Look at that. Oh, hats off. Wow. Look at the module. They've built a cube in there. They've built a cube with the power supply. Look at the big ass power supply caps in this thing. Absolutely enormous. They go right down the center like that. Yeah, there's motherboard runs under the bottom, but they've got a protective cover over the bottom of that motherboard. And then we've got, power supply board on the back here, which then has a card edge connector, which goes up to here like this. Got more card edge connectors. Card edge connectors galore on the power supply. It's a thing of beauty. It's a joy forever. And then they've got another board over here. I don't know what that one's doing, which then goes into the side rails on this board. And then, okay, we're going to fly back over here. That generates probably the high voltage. Another transformer over there. And the interesting thing is, from a thermal point of view, like a lot of the airflow, 3/4 of it goes over the CPU cards like this. But the other parts of it goes through these heatsink fins, which, ta-da, I can lift it out. Look at that. There you go. There's our power supply board. Oh, and I love the fin arrangement. Look at that. That is beautiful. Got an early sill pad. Sill pad's, the trademark sill pad wasn't around then. 45th week 78, 7th week 79 here. But yeah, there's our power supply. Isn't that beautiful? Oh, reefer madness. Oh, damn. Oh, yeah. There you go. You want to replace that bad boy? Yeah, if you wanted to get this back up and running, you would recap this entire thing. Sprague, for all you Sprague fanboys. There you go. Fantastic. Look at that. HP. Someone at the HP factory wound that, so holding the tongue at the right angle, and the card edge connectors in there. Oh, come on. This is fantastic. Oh, is that holes for trimmer pots? No, I don't know what those holes are doing, actually. Don't know. That's a mystery, but Come on, seriously, this is just absolutely fantastic. Have you ever seen the heat sinks slide into rails? Have you ever seen heat sinks slide into rails? Oh, how can you not think this is the best thing ever? Ah, engineering students, take notes, please. Look. What does that do? No idea what that does. Oh, can they label it? Anyway, yeah, it's okay, linear reg. Oh, okay, that goes up, that only goes up to the top power supply board. So there you go, just generating some extra rails there. And then that goes into these boards. There you go, look at that. Big ass bridge rectifier, big ass, oh yeah, the heatsink. That heatsink is just for that bridge rectifier. Oh, what a beast. Oh, but come on, this is just beautiful. Look at those wiring looms down there as well. Oh, come on. And as I said, the damn heat sinks have rails. Seriously, how good is this? And there's the other one that plugs into the top power supply board and down into the motherboard as well, as did this one down here that plugs into the motherboard. You can see that. And come on, that's brilliant. LM320s. LM320 at the top, 2N6338, 13th week 79 down there, another custom HP coil. Come on. September 1979. Look at that. This is just absolutely fantastic. So they've split a whole bunch of the functionality across multiple boards, and as I said, they put the railings down in there, so you put the heatsink. So this is these are basically right angle railings, so the board, once it goes in there, it can't really come out. You have to put it in like that, and you can't wiggle that out of there. It goes straight down and lines up with the socket at the bottom. Unbelievably good. And even look at this connector interface here goes to the top of your power supply board like that. Whoa, it's out of here, over there, and then that goes through your wiring harness over to these turrets over here. Aren't they beautifully prepped and wrapped and soldered? That's beautiful. Oh, and they go into, that's the printer interface that we saw before. So they're penetrators which go through the plastic, they go through the metal via these plastic things here, and that's how they get the power into the printer interface. Oh, God. Is there an easier way to do this? Yes, there is, but it's not as beautiful. So please leave it in the comments down below. Have you seen a better, modular engineered product than this? I don't think I've torn down one that's as good as this. It's so impressive. Unbelievable. It's not a real capacitor unless you can grip it like that. Look at that. Oh, sprug jobby. 17th week 79. Good vintage. Oh, and those connections over there that I thought might have been big, like spade lugs or something like that. No, turns out that they're actually, looks like stud diodes on a heatsink. Geez, it's almost an anticlimax to look at the rest of it, isn't it, after that pornography? Anyway, there's our tape drive mechanism. I'm not going to, take that apart. When you open the flap, you can see, a head in there. So obviously this is the head amplifier. I'll give you a closer up view for those playing along at home if you're interested. And that's got some motor drive as well. And they really want you to know it's made in the USA by Uncle Sam himself. And then that goes over to the obvious tape drive controller board, and that'd be no doubt another ceramic hybrid job. I don't even think I'm going to bother to take this board out and get to the bottom board under there. It's just like a motherboard interface, which, you can see the traces running under there right across. Looks like it's just a motherboard interface, which then connects to the keyboard underneath that. But anyway, so there's two of those. So, yeah, they certainly wouldn't, it'd cost a bit to populate that tape drive. It's obviously identical, so that's why the base model only came with one drive. Geez, what, you want 2 tape drives? It's an extra couple of $1,000, please, sir. But anyway, we've got this board in the middle, which seems to be some interface jobby for the tape and the keyboard and everything else. So that just goes down to the motherboard down the bottom here somewhere, and yeah, look, I'm not gonna take it all apart. It's not that I don't think there's anything really extra to see under there, and we've already spent enough time gushing over the rest of this. And the printer mechanism, I don't know, there's not much to, once again, like, I'm not going to take out the whole thing and go to town on that, for those who want to see the labels and whatnot down in there. But look, there's a big heatsink underneath the bottom of that thing, certainly. So once again, you know, all the there'd be a bit of airflow over that, not much. I think most of it. So oh yeah, as I said, like, you know, the air vents they come up from the bottom here, and as I said, it looks like, you know, a little bit of it at least, you know, maybe a quarter of it or something goes under the print mechanism and the power supplies and stuff like that right up to the back. But oh boy, that is brilliant, is it not? Come on, is that one of the coolest teardowns I've done? Come on, you got to give it. Give it up for the HP engineers. Seriously, here's a list of or like at least the people we know about who worked on this puppy, or at least worked on this series of machines. So yeah, fantastic work. And this sucker expanded barely fits on my bench. Anyway, oh, that was absolutely brilliant. So I hope you enjoyed that, just a random bunker item that was gathering dust, and that's, yeah, it turns out to be one of the best like modular teardowns that we've done. Absolutely brilliant for, like, you know, late 1970s technology, and it only had, you know, a 3-4 year lifespan, something like that, tops, before, you know, other sort of your more workstation-y type computers in the mid-80s sort of came, like late 80s, and especially when they took off in the 90s, just, you know, left all this sort of stuff for dust. But yeah, custom HP processors running, you know, their own custom basic, and it was the processors are micro code optimized for, you know, the basic routines and stuff like that. It's just absolutely phenomenal. And as I said, apparently everyone who used this thing just raved over its, you know, its ease of use and usability. It's just a well-engineered, well-executed, spared no expense computer from the late 16-bit computer, custom-designed everything from the late 1970s, early 80s. And yeah, by the end of the 80s, like, hands up, were you using this series of computers like into the 90s? Some people may have, you know, if it were, you know, if it ain't busted, don't fix it. Heck, I was still, when I left my job at Sercel, I was still using like Windows 3.11 machines in production. So yeah, that was like, you know, 10 years after they retired it or something. Yeah, crazy, but, you know, it still works. So we still maintained them, still used them, and yep, hands up if you used one of these things. Leave your thoughts and comments down below. So I hope you liked it. If you did, please give it a big thumbs up. As always, discuss down below. Catch you next time.